Okay. Take a look at these quadratic equations. Right. What does that mean? Okay. Quadratic equation. That's a factor or graph the quadratic equation. Just means it's in this format. You know, it looks a lot like everything we were factoring. It can have up to 3 different values. As you saw, though, when we were factoring like those difference of squares, they weren't. There's only 2 numbers, like 25x squared minus 4. So, but up to 3 max. Now, we're going to be using formulas that will use these values, A, B, and C. So one of the first steps for all of these is going to be, what is A, what is B, and what is C? A, and they're all numbers. Just numbers, not the variables. We have to know that A is always in front of the squared term, or the quadratic term. A is called the quadratic term. B is a number that's by or next to in front of an x, a variable. So there's always an x with a b. And C is just a number that is by itself. Okay. Do not make the mistake of thinking the first number is always A, the second number is always B. Sometimes there is no B value, so the second number could be the C. You have to look at what is it next to, what is it with. So if it's with the x squared, that's the A. If it's a number by itself, that's the C. Don't go by first number, second number, third number. I'll show you what I mean right now. Also, we want to make sure these are either equal to y or equal to 0. Okay? We usually want to have the squared term first, then the linear term next, and then that constant term last. Okay? A, B, and C on the same side, so we don't have it, 4x squared equal to 5. We have to get it equal to 0. And then, of course, for this to be a parabola, the first number cannot be 0, otherwise you have a straight line. All right, so let's just practice. Here's what I mean. We're going to identify A, B, and C. All right, so you're looking for A in front of the square term, B is in front of the x term, C is in front of the, C is just a number that's by itself. But remember, it has to be equal to 0 or y before you say that. All right, so for instance, on number 1, A is 2, right? B is 5. And C is -3, right? So the sign does count, gotta say. All right, number 2, A equals what? -1. B is 1. And C is 2. Okay, what's wrong with number 3? Not equal to 0. So we're not going to say 1, 3, and C equals 7. That's incorrect. Right, so get it equal to 0 first, then. A equals 1, B equals 3, and C equals -7. So again, we can't just look at this and say, 1, 3, 7, right? It's got to be equal to 0 first. Some of the special cases where you have something equal to 0, A equals 5, B is 0. Right, so again, we don't want to say first number is A, second number is B. So the definition was the number in front of the x squared is A. The number in front of an x is B. But there is no x here. So there is no B. The number that's by itself that has no variables, that is C. So common mistake is the first number is A, second number is B, and if there's no third number, that means there's no C. That'd be incorrect. You always want to look at, well, what number is this thing paired with? Same thing here, not equal to 0. Get it equal to 0 first. So this time you see how we have a square term, so A is 1. We have an x term, so B is -8. And we have no just number by itself, like we have no like -3 or +6 or anything. So that means it's 0. Number 6, similar. A is 4, but this time there's no x term. And there's no number by itself, so those are both 0. So these are all the cases where you can have zeros. There's a 0 for B, you can see it's just a square term and a number. If the 0 is C, there's just the square term and the x term. If they're both 0, all you have is B. square term. Of course, here, make sure you get it equal to 0. So we're clear on that. Now it's going to be, this seems like something small and insignificant, but you do need to do this correctly, otherwise nothing else will be correct after this. So here's exactly what you'll be doing today. Graphing something. Okay. However, it's not going to give you the x values to plug in, so it's not going to be nice. So you're going to use instead, you're going to use this other formula. X equals negative b over 2a. Now, you might have seen this before. It actually came from something like this. Root familiar? Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, it's this right here. It's that part of the quadratic formula. So we'll be using that full formula next week, but for now, we'll be using the first part, the axis of symmetry. It's called. It's the exact middle of our graph. So, of course, it depends on us knowing what A and B are exactly. Notice when I plug it in, go ahead and plug in B and A. See what you get for your answer. What does X equal on here? Calculate that really fast. Maybe on the side of the paper I have down. What do you get? Okay. Negative. Okay. Now, did you plug it in? Did you plug it in exactly as is? So you notice the negative of the formula is different from the negative of the b you're plugging in. So you actually have a negative here, a negative here. That's why you end up with 2. So we get 4. Positive 4. Very important. So we know the center of our graph is going to be right here. And now we can figure out, well, where is the actual vertex? Where's the point of that parabola going to be? Plugging in 4, see what you get, back into the original problem. Just like you did last time. That part is the useful. The only thing different is, again, I'm not going to give you the x and where to start. Here's the formula to use to start off. You need to identify A and B, make sure it's equal to 0, and so on. And that will give you a starting point. And from there, we're going to do kind of the same thing. We're going to plug in some points above and below. But this time, we're going to use the fact that we know we're going to get those pairs of answers like last time. So like 0, 6. I know that's right here. But instead of plugging in some more points and finding out, hey, that's going to be the same answer, I'm going to use the idea that that pattern is always going to be there. So if I know that a point is, let's see, 1, 2, 3, 4 away from the axis of symmetry, you also know there's another point on the other side 4 away. I don't have to go ahead and plug in whatever number this is. Looks like it's 1, 2, 3, 4, 5, 6, 7, 8. I don't have to plug in x equals 8 to find out that the answer is going to be 6. We know from last night's homework you're going to get pairs of answer. So that's going to speed up the graphing process by using this symmetry. Again, if there's a point down here, that's 2 away. We know there's another one on the other side. That's why I mentioned when I'm checking your homework. If you don't have points directly across from each other, something is wrong. They always point pairs. All right. That's going to be your process for each of these. Using this negative b over 2a. The first part of the quadratic formula as our starting point. So you might have remembered, like when you're graphing straight lines, we always started at the y-intercept and then did the slope. Here, you're always starting at the vertex. So you have to find that vertex and then pick points. And go from there. All right, so let's look at the homework. Do a few of these together, then you'll have some time to work. All right, so we have to find, mention this min and max part. A little bigger. We have to write the equation of the axis of symmetry, find the coordinates of the vertex, graph each function, identify the vertex of a min, or a maximum, or a minimum. Okay, talk just a little bit about that. So in other words, when you graph it, let's see here, do this. When you graph it, it's going to be opening up. When this is positive, and the vertex, which is right here, is at the lowest point of the whole graph. It's up here, it goes down, down, down. It's a low point, it's a minimum, and it goes back down. Anytime it's opening upwards, the vertex is at a minimum point. How do you know when it's opening up? Anytime this a value is positive. No matter what this a value is, as long as it's positive, it opens up and you have a minimum. If it's opening down, you notice you have a maximum. It starts down here and it goes up, 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 comes back down. It's kind of like throwing a football up into the air. It gets to this highest point and then it starts coming back down. So anytime it's opening downwards, or a is negative, you have a vertex that is alright. So now we know, without actually graphing, we can tell if you have a min or if you have a max. Maximum opening down, a is negative, and so on. Going back. So on this particular problem, do we have a min or a max? Let's do it first. By looking at that number. Which way will this be opening? Up or down? Up. Okay. So the vertex will be right here. Is that a min or a max? That's the top of the graph or the bottom of the graph? Bottom. That's a better one. So we can answer this question relatively quick. And I can give you any sorts of crazy problem. I can give you like this, 170, making this up. Minus pi. Give you any sorts of quadratic like that. And say, is this going to have a minimum or maximum? Right? Well, none of this will matter. You're just looking at, is this positive or is that negative? Positive, it's opening up, so you have a minimum. That's all you need to verify. All you need to verify. So, first part done, let's do this. What does A equal? What is B equal? And go ahead and calculate the axis of symmetry. See what you get. So A equals 4. B is 0, no number. So we can just get 0 over 2 times 4, which is equal to 0. X equals 0. What does that tell us? Axis of symmetry, x equals 0. It's x equals because it's a vertical line. All vertical lines are x equals. So this is the center of our graph. We're also going to make that the center of our table. Now, this is what you weren't given yesterday. I didn't give you these values. I didn't put that vertex there right there in the middle for you. And have it already set for you. And you just have to calculate it and figure it out now. Let's see. So let's plug in 0. What do you get when you plug in 0? Yeah. So we get 4 times 0 squared. So we get 4 times 0, which is 0. Yeah, so that's just that 0 comes in. That's right there in the origin. Okay, that's the vertex. And we already know it's opening up, right? We have a min. So this is going to be the lowest point on the graph, so I expect it to go this direction. So now we're going to pick some points. Let's pick one above. And if I'm going to pick one right above 0, I'm going to pick the same distance below 0. So we want to go the same distance in either direction. So from this point, now it looks exactly like something from last night. We've done some work to get to exactly where you want to be. And just plug it in. Plug in a few. What do you get when you plug in 1? Y equals 4 times 1 squared, which is 4. 1. Now, I know that this point is 1 away from the axis of symmetry. So I get buy 1, get 1 free. I know there's another point exactly on the other side, which is this one. I know they're both going to equal 4. So this is what's going to save us some time. We saw this pattern yesterday where we could graph a little bit faster. We didn't have to plug in. We don't have to plug in anymore every single point just to find out that they're always going to have two of them are going to have the same answer. Okay. And if you plug in 2 on this one, 4 times 2 squared, you end up with 4 times 4, which is 16. Just off the chart, so we're really not going to be able to graph these two. 16. But we know they're the same, but our graph only, our y value only goes to 10, so we'll just have to do that. And be careful, make sure when you graph these, never don't go straight up and down. And then make a nice smooth curve at the bottom. It should not be pointy. It should not be pointy at all. It should be rounded at the bottom. There you go. We answered each question. We know the axis of symmetry. We have the coordinates of the vertex. We did graph the function. And we did state them in that. So 4 different things, all political directions, make sure we covered them. Now that's a little bit easier because there's, axis symmetry is 0, the vertex is 0, 0. Makes it a little bit easier calculation-wise. Let's go to something that's a little more closer to what we did last night. 9, about 21. Open up and open down. What do you think? Is this a min or a max? So what does this tell you? Opens down, so you're going to have a max. Identify that rather quickly. Without graphing, without doing anything, just identifying the sign of A. Sign of A. Okay, write down the formula for the x symmetry. Write down it. By writing it down before you actually calculate it, it'll help you memorize it. Of course, the most common mistake I see on this is forgetting the negative. It'll be over 2a, so every graph will be off completely because of that. So be careful. So what is A? Negative 1. What is B? Negative 6. I'll be saying that exactly. Go ahead and calculate that and see what you get for B. Alright. See if you get the same value either. I have negative, is that right? No. What's wrong with it? Yeah, so remember that this negative here does not count as this negative here. So it's negative of negative 6. Negative here does not count as this negative. So one negative with the formula, and the number you're plugging in is also negative, so there are 2 of them. So all over 2 times negative 1. So we have positive 6 over negative 2, which equals negative 3. So the center of the graph is going to be at negative 3.
Wouldn't the top be 36 because 6 times 6 squared is 36? Or you, oh, okay. Yeah.
This is the middle of our graph, negative 3. Same thing with our x values, put it in the middle, negative 3. Always put that number right there in the middle of your key chart. Okay. Now, we know this is opening down, so we expect to have the vertex probably up here somewhere, and then it opens down this way. It helps to visualize where we're going before we do it. You can expect something up there. All right, so let's plug it in. Here's where you got to show that work and make sure you're absolutely certain of your arithmetic. Negative. Negative. So write that down, go ahead and calculate it, see what you get. What you get on that? Now, what if you get something that's off the chart? Probably did miscalculation. Show all the steps just like you did last night to make sure it's correct. Okay. Otherwise, you're just hurrying up to get it wrong, which doesn't make sense. Slow down, let's get it right. So we have negative 9 plus 18 plus 15. Okay, why is this negative 9? Yeah, so negative 3 squared is 9 times the negative in front. Okay? Negative 3 squared is 9 times the negative in front is negative 9. Do not do negative times a negative and then square it. That would be out of order as far as the order of operations. You're doing multiplying before the exponent. That's an issue. Exponent, then multiplied by the negative. Okay? So we have negative, see, 18 minus 9 is 9. 9 plus 15 is 24. And that fits. 24. So our vertex is negative 3, 124. Now let's pick some points. At this juncture, you might pick different numbers for the x's. So on the last one, I just went like up 1 and down 1, but you can go up 2. You can go to like negative 1 and go the same distance the other direction, right? So if I went 2 this way, I got to go 2 the other way, negative 5. I always recommend plugging in 0. That's an easy number to plug in. Why not? So that's 1 away from this negative 1, so 0 is just 1 away, so I'll go to negative 6. And by doing the same distance thing, I'll know that these two answers will be the same. So we're not going to waste the time doing all that work just to find out, hey, they're both the same. Oh, they're both the same again. We're going to know that ahead of time, but we got to choose these numbers wisely for that to happen. We can't choose them randomly. Now, if you chose negative 2 and negative 1, that'll work too. So there might be some differences between you guys' work. It won't mean it's wrong. As long as you have the same graph, the same vertex, it's okay. There will be some variations. All right, so let's try it out. Plug in negative 1. What do we get? Okay, go ahead, try that out. Calculate it. See what you get? Okay. I got 20. Is that what you got? 20. So I'm going to go to negative 1 and go up to 20. And I know, because this is 2 from the axis of symmetry, there's another point that's 2 on the other side. So that's negative 5. You'll also get, I need the up one, don't I? Exactly across. Okay, I'm going to get closer. Right there. Okay, got exactly 2 away. Straight across from each other. So what stopped me just now is that I noticed that these weren't exactly across from each other, so that was a red flag. That's not right. They've got to be exactly across. Okay, so that means I can plug in negative 5, and I know that answer is 20 also. I don't have to do all this work again just to find out, hey, it's the same number just like before. All right. Plug in 0. What do you get when you plug in 0? Yeah, 15. Don't really need to show work on that. It's like, okay, 0 minus 0 plus 15 is 15. Anytime you plug in 0, your answer is always just C. So that was nice. That's also called the y-intercept, by the way. And again, we don't need to waste the time saying, okay, that's 3 away, then I go 1, 2, 3 the other direction. I also know if I plugged in negative 6, that's going to be 15. And it's the same distance, always in pairs. Think about this process right here, kind of like rise over run when you're doing a straight line. You know, you need a starting point, and then you need a way to find out what the next point is. That's kind of what you're doing. We have a starting point, which is the vertex. We figure out one point, and then we need to figure out another point. That's when you go and do this, and you get another point. Okay? Plug in a point, you get another point for free. And then go ahead and graph it. Yes, you can. Should be symmetric as possible, all the way down. So any of these, if I go 5 this way, it should be exactly 5 this way. So I can see this side a little bit wider. Always the same distance all the way down. And the more points you use, the more accurate it'll be. That's your plan, that's your goal for today. Right there. Now, I want you to identify this. When the parabola is opening down, think of the object going up in the air and coming back down. So say this was feet on this side. How high does this object actually get off the ground? What's the maximum height here? Yeah, you can see over here's the very top. That gets up to, okay, it gets 24 feet up in the air. So that's from the vertex as well. So on the back side, there's a word problem that talks about something going up in the air, okay, and it's asking you for the maximum height. Okay? So that's kind of like find the vertex. It goes up and comes back down. You just need to find the vertex, and that'll let you know how high it is off the ground. So associate this maximum height with this maximum height. They're one and the same. Okay? One and the same, and it'd be 24. That can help you out with that. Okay. Okay. Well, rest of the period work. Try to get started on each one. Like do the negative e over 2a and have your vertex finish for each one, and then the rest of it you can probably finish